Thank you. We're now ready for our first panel discussion of the day. We have assembled an electric lineup to discuss the manufacturing energy storage for renewable grids. I would like to invite the panellists onto the stage and welcome our expert facilitator, Joe Hemingway, Manager of Network Strategy for PowerLink, to introduce the panellists. Joe.
Thank you, everyone. So my name's Joe Hemingway. I'm the Manager for Network Strategy in the PowerLink team. And what our team's really focused on at PowerLink is really looking at those holistic needs across the network in terms of large-scale generation, storage and transmission investments that's needed to really achieve that kind of low emissions future at lowest cost to the consumer. We see the role of batteries quite critical to that transition. They already provide a lot of value today in terms of those really short intermittent energy and system services. But as we kind of move into a future where we've got higher penetrations of renewable and variable renewable supply, that's not always going to match when the load requirements are needed. And we really see that batteries play a really key role in terms of that energy shifting over time to when that load is needed. We're really excited to hear about the range of new technologies that are being developed and how they can support and the value propositions that they provide in providing those services, and also what local manufacturing opportunities are there to develop and support and facilitate the energy transition. So with that being said, I might start with our first question. So what are the and thanks to everyone here. We've got Jeremy Peters from the Vecco Group, Thomas Nann from Allegro Energy, Craig Sainsbury from Australia Vanadium, and Adam Best from CSIRO. So what are the range of technologies that you're currently investigating, and what value do you see that they provide as part of the energy transition? Might start with you.
All right, I can make a start. Yeah, thank you very much for the introduction and for inviting me on this panel, Lynette and Quentin. So I'm a former academic turned entrepreneur. I spun out a company with two co-founders. It's called Allegro Energy. And what we are building is built on a flow battery platform. I know we've got more flow batteries here on the panel, but we are not using vanadium. Our IP is a new type of electrolyte. It's called a microemulsion electrolyte, and hence a microemulsion flow battery. If you want to know what that is, please contact me in the break. So generally flow batteries, and I'm sure my colleagues will talk more about this, are very well suited for long duration energy storage, which is an emerging need as we transition into a renewable energy economy. So at the moment we still get away with short duration storage, but there are lots of modeling and lots of studies that show that this is a transition phenomenon, and rather sooner than later we will have to invest into long duration storage. And what is critical for that is that we provide scalable and economically viable solutions for that, and this is what we are doing at Allegro.
Thank you. So good morning, everyone, and thank you again to Lynette for the kind invitation to be here today. So I'm not a flow battery guy, but tooling around a little bit, but my main area of interest is obviously in lithium-ion technology, and particularly supporting the development of lithium-ion battery systems and including the supply chains that live in behind that. And we see plenty of opportunities at the moment with the transition towards clean energy, and particularly the opportunity for Australia to transition its critical minerals endowment into value-added battery active materials that can not only support a global demand but also support an Australian local demand. Part of this work we've obviously been doing for quite some time through Energy Renaissance, where we've developed some of the battery energy storage systems that they've been developing over the journey, and we're about to announce hopefully in the next couple of weeks a pretty exciting opportunity with them as well, in order to try and facilitate further the support for Australian uptake of batteries, particularly for the home energy storage market. As we know, we have so much solar now on the Australian energy grid. The duck curve has become a real problem, such that we're now entering into long periods of curtailment. So whatever we can do to add more energy storage to the grid in order to support the transition to clean energy, and also try and reduce people's power prices, I think is a really important piece of the work ahead.
Great, thank you. Craig Sainsbury, not as technical minded as my colleagues here, ex-investment banker and mining engineer, but stepped into a role with Australian Vanadium because could see the huge opportunity that could come from battery storage, and picking up on something that Leanne mentioned, bringing that expertise in terms of accessing those capital markets to unlock the opportunities that we've got before us. Quickly with Australian Vanadium, we're trying to capture the full value chain from mining to metal, or megawatts to minerals, as Leanne was saying. We are deploying and looking to continue to deploy vanadium flow batteries, and it's not a new technology. It's been around for about 25 years. It's new-ish to Australia, but in China, I think the last count, there's about 24 gigawatt hours worth of...
There was just the 40-year anniversary of the vanadium.
It was. It was about in New South Wales a couple of weeks ago. Yeah. So 40 years, and China's, with a lot of things, taking the lead on this, partly because they've got access to almost unlimited capital. But we are, and you may have seen from some of our releases, we've announced what we're calling Project Lumina, which is looking at putting our 100 megawatt, 800 megawatt hour battery into the grid scale to really start to compete with a lithium batteries, but really pick up on the need for the transition of power over a longer period of time, and really transition that solar that's being curtailed into those peak hours. So we've got some small batteries that have been tested and deployed. We've got an electrolyte facility to make the vanadium electrolyte in WA. And the real piece of the puzzle for us here, and I think the real value unlocking a lot of the supply chain, both for us and the vanadium industry in Australia, is the mine, or the project that we have in WA. So one of the world's largest untapped vanadium deposits. And I think if we can, with other parties that are looking to develop flow batteries, get an industry here, it can unlock that electrolyte, so the middle part of that supply chain, unlock the mining. And what we can do that we didn't do in lithium, and this is kind of the real exciting bit here, is Australia can potentially be a leader in that flow battery technology and really create some significant jobs for the community and have a lasting legacy. So I'll get off the soapbox a little bit and come back onto it, but there's a huge amount of opportunity.
Thanks, Craig. Is that one on? Thanks. Jeremy Peters, Vecco Group. So we are an integrated vanadium mining manufacturing company. Our deposit is in Queensland, in Julia Creek, a little bit east of the one Craig talked about at AVL. And we have focused on starting the supply chain in the centre. So we've created an electrolyte manufacturing facility in Townsville. That facility is currently operational and capable of producing 35 megawatt hours of electrolyte for vanadium flow batteries annually. And we see the centre of that supply chain in the electrolyte as key, and that's why we focused on it first. The vanadium electrolyte is where the energy is stored in a flow battery, vanadium flow battery, and that's the key piece of material that would need to be imported alongside the hardware to get the batteries operational in Queensland and in Australia. So focusing in on the centre then allows us to expand out. As I said, we're manufacturing now. We've deployed a battery with EQL, with Energex at their Berrinbar depot. That battery is using Sumitomo Electric hardware. And we've joined a collaboration agreement with Sumitomo Electric, Idemitsu Australia, and ourselves to really accelerate the vanadium flow battery supply chain on the east coast of Australia, mainly focused at the NEM. So the benefits, as my colleagues here have already pointed out, long duration energy storage at scale really brings the cost down in a very competitive LCOS. I'll just add that that doesn't preclude the technology from operating in the transient and sub-second, sub-cycle space. You can use these batteries for frequency control. You can use them for inertia. You can use them with grid-forming inverters. So that's an application of the technology that has been used, and Sumitomo has a battery in Hokkaido that does just that, but it's not as well known as its long duration aspects. So just wanted to add that into the piece, and another value stack another value add in the stack to consider for customers.
Great answers, and it's great to see a lot of the diverse range of technologies and the different services that they can provide. Changing the shift to kind of manufacturing now, I guess more broadly, what do you see as the benefits to manufacturing locally, and what do you see as those real key challenges or barriers to investment to facilitate that?
Okay, I can make a start again.
Thank you.
So we're just about to deploy our first commercial pilot, which is super exciting. But what that meant is that we had to build a supply chain over the last year or so. And I have to say this was a very interesting exercise for me, and reflected where we are in Australia quite clearly. So I mentioned earlier that we have the philosophy that we want to build things for scale. So we designed, all our engineering and design was from the start straight for scale. And what that meant is that we want to tap into local supply chains as much as we can. And one big advantage of that is not only it supports the local economy, it also supports the replicability of that model. So if we went to some other country or some other continent, for example, and we have that built up locally, then we can just replicate the same thing, which I don't want to say cuts corners, but let's say it's highly efficient when you think about scaling. But more in terms of challenges, what I really learned about the Australian manufacturing landscape is, so there are certain things we need in our batteries. So there are relatively simple things like steel frames and plastic pipes and plastic tanks and this sort of stuff. And we have no problem at all sourcing that locally and having that made in Australia. But when we go one level higher in sophistication, for example, membranes for our reactors in these batteries, or the electronic components that we need in the power electronics, and I could go on and on and on, chemicals, for example, nothing of that is being manufactured in Australia. So what I see is there's this huge void. We have this, let's say, low-tech manufacturing industry that's working well. We've got the very sophisticated and great universities, and then there is a void in the middle where just nothing is there. And I find this is the most challenging bit. And I think when we think about building manufacturing, battery manufacturing in Australia, we also have to think about all of these other industries that feed into this manufacturing. And I mentioned membranes already. So every lithium-ion battery has got a separator. Every flow battery has got a membrane. Reverse osmosis plants needs loads of membranes. It's all very similar technology, and there's not any reason why we don't do that in Australia. So I think we have to think bigger and broader, and about horizontal and vertical integration as we build this industry. Sorry, that was a bit longer. I shut up now.
No, I think it's a really good segue into the challenges for lithium-ion batteries. And I suppose as our last CEOs used to describe it as a wicked problem, because everyone wants to see lithium-ion battery cell manufacturing here. But sure, you can go and buy a $20 million line and install it in a factory, but you'll be importing everything that you need in terms of process materials, electrolyte, cans, foils, the works. There is none of that being made in Australia. So Thomas's problem is replicated very clearly in the lithium-ion space. And we are moving towards some of that supply chain piece. And I think there's a real point where we have to walk before we run. And I think one of those key pieces is being able to at least make high quality cathode technologies and also anode materials, particularly graphite. And we're well placed for this in terms of particularly natural graphite in Australia. We're finding more and more resources, and we'll release a report shortly with Stanford University on Australia's natural graphite resources and opportunities to find more. And we're also doing quite a lot of work on cathode materials as well. And what are the types of opportunities that we need to invest in order to build an industry around that? And we at CSIRO have started that journey. We've signed a relationship agreement with Panasonic Energy, and we're working with them now on nickel sulfate, high-value nickel sulfate materials, with a view to a much bigger and broader partnership in the next year. So please watch this space with that opportunity, because we can't just build this for Australia. We're not a big enough market. Whatever we do, we must have a global view of this, that we have an export focus that then supports domestic production. Because without that, I don't see how we will have a sustainable, long life industry that will provide the types of jobs that we need. Because I think without that, it will make it very difficult to even go further down the value chain.
Well, I'm going to answer that question in a very different manner. I think what we're trying to achieve with scalable rollouts of VFBs and understanding what our customers want, risk is a massive issue for them. And technology risk is an issue, funding risk is an issue, and offtake risk is an issue. So I think when we're looking at manufacturing in Australia, we need to think about where we can diminish risk, where we can maximise returns, and where we can maximise the allocation of capital to new technologies. So to give you how we're thinking about pulling that together, for something like a vanadium flow battery, as I was saying, the technology is proved. It's worked. We've got Japanese, Austrians, Chinese, South Koreans. There's a range of really good quality OEMs around the world that are delivering VFB cell stacks for us. Now, do we need to impart risk into a VFB by manufacturing our own cell stack in Australia? I would question that. Can we do it cheaper than it can be done offshore? I don't think so. But when you look at the overall VFB, that cell stack is looking in the order of about, it depends on the duration and size, but you're looking in the order of about 15 to 25%. Now, the rest of that supply chain, we can control in Australia. Okay, so de-risk by using some offshore technology, increase local content, and I think that's the key thing, is how can we increase local content, how can we increase jobs? So if we'll look at, and I'm sure Jeremy will say the same thing here, when you look at the electrolyte, and that's, I guess, why you've gone here, the electrolyte is between 40 to 60% of a battery, depending on its duration and size. We can control that in Australia, we can make that here. Within that vanadium electrolyte, it's vanadium. Right? We don't mine vanadium at the moment. That's coming generally from South Africa, Brazil, China, but we've got 40% of the world's reserves. So when I look at that from purely a manufacturing standpoint, yes, there will be some new technologies that will need to be manufactured here, but I think there's other technologies that are proven where we can bring in that technology of cell stacks from offshore, de-risking a project, enhance the access to capital, enhance the path to market, and create a really strong and sustainable local industry here with a high level of Australian manufacturing. So it's a slightly different way of answering the question, but I think that's what we need to look at, is that balance between manufacturing and technology, risk, access to capital, pace to market.
It's always tough being at the end of the panel, isn't it? You know, got to come up with some unique ideas. No, look, at risk of saying something the same in another way, I think for local manufacturing, particularly for VFBs, you've got to go, does it make sense? What scope makes sense now? Can it scale? And then how can you improve on it in the future? So does it make sense? The liquid electrolyte makes sense now. You know, we can manufacture it in Townsville at a competitive rate to what you could import it from China. That makes sense. To Craig's point, creating a cell stack now wouldn't. Can that scale? Yes, it's a very simple process on the outset, and we have a lot of the materials here already with the vanadium to come. So we'll take sulfuric acid from Korea Zinc in Townsville. We get water in Townsville. Cleveland Bay Chemicals, who are here, supply us with both of those products at the moment, but they're from the local area, and that goes into the battery. And we import the vanadium. That process can scale very easily. We've got a train that is essentially the smallest commercial scale train you could make in Townsville now, and we'll essentially multiply that or duplicate that to achieve 300 to 500 megawatt hours of production in Townsville at our next site in Cleveland Bay Industrial Park. So does it make sense? Yes. Can it scale? Yes. What are the chances for improvement? So we know that the hardware that's manufactured offshore is being automated now. You know, these OEMs, the Sumitomos, the H2 Incs, the Cell Cubes, the Infinities, they're improving their production capacity and capability now. Once that is at a point where it is automated, there is absolutely no reason why that couldn't be done in Queensland, adjacent to our electrolyte facility in Townsville. So that long-term horizon of how can we improve this product, how can we really make it a game changer for Queensland and for Australia is there. And to add to that, when you have the local demand for a product and you have the middle of the supply chain capable of supplying it, you enable the mining. 40% of the world's reserve, the best reserve, sorry to say, Craig, in Julia Creek in Queensland. We can unlock that, we can send it east to Townsville, we can send it on a ship to the US, to Europe, as high purity V2O5, and we can scale our manufacturing in those locations as well. So we're in the progress of identifying sites in Texas to do just that. Manufacture electrolyte using feedstock from Julia Creek. The shipping component of the battery in V2O5 form is a fraction of 10 times less than what you're shipping with electrolyte. So that makes sense. Can you scale? Yes, you can ship more and you can manufacture more in Texas. It's the same process that we're using here. So if it makes sense now, you can scale and there's options to improve. I think it's a no-brainer and something that we should be looking at more, doing here with the capability and the resource that we have.
Can I respond?
Absolutely, yeah.
So I want to comment on the stack issue. I don't totally agree with that, and I also think it's different for different technologies. So in our case, more than 50% of the cost is the stacks. What we did this year, we actually imported them. We didn't make our own stacks. And the only way to get the cost of this down is to make it ourselves. So what we do is we license the design from our current supplier and replicate that here in Australia, and that is indeed way cheaper than importing it. It might be different for vanadium stacks, so we use almost the same technology, it's just a different membrane, but other than that, it's more or less identical. But for us, it makes sense to make it here. And just one other quick comment. So Craig mentioned in his talk earlier that in WA, lithium ore, I can't remember exactly what it was about 20 billion was exported to China, but that's about 2% of the value add when you then re-import all the materials. And I have questions about this. I don't think this is long-term sustainable. I'm of course not an expert in finance as you are, Greg, but I just wonder, is that really long-term sustainable, this stick and ship approach, and just import everything and let someone else add the value?
We'd 100% agree with you. I think what we've seen from whether it's been iron ore, whether it's been aluminium, Australia's been great at digging it up, sending it to China to manufacture and transform and importing it back. And I think with things like vanadium, whether it be out of Queensland or Western Australia, we've got the ability to keep that value add domestically. But just picking up what you said on the cell stacks, I think it's a really important point here is different technologies at different parts of their life cycle will have different strategies in terms of a go to the market. And I think that's really important. But I think also with where the market's going to, and we can all recite figures, I think it's 32 gigawatt hours worth of medium duration energy, AMO said by 2032, I think it is there or thereabouts. There'll be so many winners that will come out of that domestically. But I think we just need to make sure that people will attack it in a different way, and that's great. And there'll be people who look at a little bit more offshore content to de-risk. There'll be people who'll be bringing manufacturing locally because it will be cheaper than you can get offshore. And so I think that's the great thing about what we have here in Australia is there's different parts of the value chain that we excel in, and different technologies will be able to leverage different parts of those value chains to excel in and generate what we hope to be sustainable returns.
I'll just add briefly on your point, Tom. I think it really highlights the stage of the technology and the different challenges in different stages. You're obviously creating a product that's new, that's novel and innovative. That was happening with VFBs 40 years ago, as we learnt from the recent anniversary celebration. So unfortunately, that's been commercialised overseas, and that's why I think it is the difference in the pathways that you just described is it's already commercial, they've worked out how to do it cheap to a point, and now it's really going into more of an industrial phase of how can we scale that commercial capability. And I think it's just a nice way to highlight the difference in the depth and breadth of the battery supply chain. Here we've got 2 flow batteries. From the outside, someone could assume a very similar in different stages of the life cycle and learning process and opportunity in front of them.
Thanks, everyone. That was some really great points there around where you can the ability for local sources of these parts of the supply chain and how you can really de-risk it. The next question is probably a bit more nuanced and probably a bit more selfish from my perspective, as I'm a modeller by background, and we're keen to hoover up as much information as possible and help to unpack that and then effectively value that and take that forward when we provide advice back to stakeholders and policymakers. What are those? What do you think are parts of those key information that something like modelers and modelling teams and analysis should consider and to more effectively value these technologies and really kind of try to put that front of mind for decision makers?
You start.
Start, Jeremy. Yep.
So I mean, you need to have a need that is long duration. So you need to be looking at that 6, 8, 10, 12-hour duration. You need to see value in a robust asset that can last for 30 years. I think the report that Craig mentioned earlier was looking at 40 years of operational life for a vanadium flow battery with some midlife changes. You need to appreciate a robust piece of equipment. You know, we're talking about energy systems in Australia and around the world that haven't changed for, what, a century? Realistically, you look at distribution networks, transmission networks, power transformers. It's the same stuff, you know, that's been around. The innovation in the space has been incremental. There has been meaningful innovation, but we haven't seen the change that we have seen recently with inverter-based connections to grid and everything that goes along with that. You need to value that again, you know, taking transformers out of life after 75 years, they were built for 40, they got to 60 and were still going okay, you take them out at 75. You need to take that view on a battery. This is not a transactional, replaceable item. This is a piece of your electricity network that is robust, that is reliable, that will last the test of time. You need to value that again. I don't think it's valued at the moment. You know, I think we're essentially consumerism in our grid. So working out how to value that, getting it back into the fray in terms of economic assessment. And then you've got everything else along with. So the depth of, you know, the more technical aspects in terms of depth of discharge, wide range of operational temperatures, that initial sub-cycle response that I mentioned earlier. Once you unpick and unpack these benefits, and it takes people like you, Joe, and you know, we should probably turn a few questions around to you, frankly, into how you can help us get into your head. But once you spend the time and unpack that, you will see where it will benefit. And you need to be future looking because some of those benefits aren't today. They're post-2030, they're 2035. That's my take.
Thank you.
Where do we start with that? I could probably talk for 20 minutes on this, so people grab me after I can talk through some more of the benefits of vanadium battery. But I think from purely a modelling standpoint, and maybe it's my background with sort of financial modelling and how we think about this from a commercial standpoint, I think modelling it, we've got to understand the benefits of new technology versus incumbent technology and how that can shift incumbents to look at accepting new technology. So for flow batteries, it's duration, depth of discharge, the cycle rate. There's a lot of things in there that I think VFBs can bring that I would say are better, but just different to what lithium-ion batteries currently have. But if I pull the commercial hat on and think from a modelling standpoint, how do the modelling, what modelling that we do, how can that help unlock the value chain that we're here today to talk about? And I think what we need to do is we need to show that new technology is either better from a technological standpoint, or it is on relatively the same cost from a deployment standpoint. So therefore, people who are investing into this are getting IRRs, internal rate of returns, that sort of justify that investment. Because the government's only got so much money to deploy, and even now with the government, they're looking to get returns off that capital. So I think to really distill it down, and you'll hear most battery people talk about an L cost, so levelised cost of storage. I think what the industry needs to do is just have a look at how it compares versus lithium, and there's some pretty good data out there around that, and we've done work to show that on a 4 hour, we're kind of competitive, but probably at 4 hours you'd still think lithium would be the way to go, because the benefits don't outweigh the accepting of that new risk around a new technology, a new partner. 6 hours plus, still into that 8 hour range, flow batteries are giving you a levelised cost of storage significantly below lithium, plus they give you that duration, all those other benefits. So I think you need to look at it, the benefits that are brought, and then what your cost is, and if you can do that better or in the same as an incumbent, you'll generally start to see your technology deployed.
Yeah, I think I'd agree with that. So obviously with lithium, we're seeing huge deployments now, particularly in the FCAS market, and that's where it obviously made its name. But we're now seeing it moving beyond that now into particularly in industrial commercial. And yesterday I was involved in some agriculture work where now farmers are actively deploying lithium solutions onto their farms in order to be able to do at least 4 hours. In particular, if we take one example is dairy farming, particularly the early morning milk, you can now basically run that on renewable energy. And this is a dual-fold cost saving for farmers. And number one, they no longer have diesel generation issues there, so supply of diesel, maintenance of diesel generators, grid connection, sometimes depending on where your farm is, that can be a pretty expensive connection, and also has maintenance requirements attached to it. And also you're now looking at also some of the carbon benefits as well, so where farmers can now actually try and actually capture some of the carbon credits that come with running from renewable energy. So lithium has proven to be very robust in that environment, and we've also seen it now deployed in community batteries as well, where particularly in inner city suburbs where people may have solar, they may not actually be able to have their own battery, but they're now able to partake in the benefits of renewable energy as well through the deployment of those type of systems. So I think one of the key pieces about batteries and where they come, and something that can't really get a number on it, is around that equity of the transition. At the moment, we're seeing those of us who have the deepest of pockets, who can enjoy electric vehicles and so on and so forth. But how do we actually make sure that there are those in the transition are not left behind who may not have the wherewithal to be able to afford solar panels or battery sets in their homes and are wearing the costs of high energy prices? So where we can actually see how we can actually distribute these benefits further, to be able to show that there is benefits to the broader community as we move forward, I think is something else I think we need to capture as part of this story. I think that's something that we can't forget, that everyone needs to benefit from this, not just maybe industry or commercial, or those who can afford it.
Yeah, so a lot has been said, and I agree with all of this. It's difficult really to bring another aspect to it, but I think there's one thing that hasn't been mentioned. So as we all know, we are in a transition period at the moment, and we are also in a free market. So the current market electricity spot prices are determined to a large degree by the specific mix of fossil fuels and renewables that we've got right now. So the famous duck curve, the spread between the belly and the beak of the duck is enormous at the moment, but it won't stay like that forever. But what that means, if you look at the market right now, it just doesn't make sense to put in long duration storage, because that actually dilutes the revenue if people are just load shifting from midday to the evening. I think one thing that you were asking about modeling and the long-term view and the input is, I think that especially looking forward, that needs to be taken into account. And quite surprisingly, when I'm talking with customers, many of them don't do that. They think about the here and now, and here and now the only thing that makes sense is lithium in the grid. But that will rapidly change as we phase out fossil fuels. And I think that is important for modeling and to communicate that, but it's also important for policy. So in New South Wales, where we are located, there was this long discussion about what is long duration storage. Is it 4 hours or 8 hours? And I'm sure all of you have been involved in this as well. And if that is important, actually, that what the politicians and policymakers think about this, because if they put policies in place that favor 4 hours long duration storage, that will wipe out flow batteries sooner or later. And in order to survive until actually we need this diverse mix of different technologies, and not only survive, but thrive into it, it is really important to look beyond this transition period.
Can I just add one thing into that from a modelling standpoint that we should think of that we don't? And I don't think this is captured when we're talking about LCOS either, is sustainability and then end of life cycle of the battery that we put in. So, flow batteries are proven to be over 40 years worth of life. The electrolyte can get refurbished and utilised again. And Sumitomo have done some work on this where they're looking at over 99% end of life of their VFB can be reused or recycled. And I think what we've seen from the energy transition so far is there hasn't been, transition's all about sustainability, right? I don't think there's been a lot of thought that's gone into the second and third derivatives of what we're trying to do from a transition. And, I've all heard the stories of turbine blades being buried. Right? What are you doing with a lithium battery that's been run hard and after 10, 12 years is degraded and needs to get reused or recycled? So I think, from a modelling standpoint, financial, government, whomever, I think there just needs to be a thought process on sustainability and then end of use of that asset.
I'd like to just add one other piece. That we've talked a bit about durations of storage here, so lithium and 4, 8, 12 hours. I had the opportunity to meet a company in the US recently who were talking about 100-hour storage. And they actually have created, with the state of California, a 100-hour storage market, just by describing what their technology can do, how it can work, and how it can support the grid. This was not even a market until they created it. So there are opportunities, I think, to be able to better define how batteries can be used, where they're going to be more suited for different applications. Again, I think there's horses for courses here. I don't see lithium solving everything, though some may suggest I say otherwise. I think there is a lot of room for other technologies, and I think this is a classic example of, well, if not every technology is going to do the same thing. So where there are opportunities to create new markets that may actually enable new areas or support the grid further, I think these are things to think about too.
Yeah, just to add to that. You're right. I mean, in terms of the current energy market, as Thomas described it, those drivers are purely economic. Fortune favours the brave, as we saw with the initial Tesla battery at Hornsdale, for markets that weren't understood yet. And particularly when you're entering into an emerging market of long-duration energy storage, if you're not in it, you don't know what benefits you can have. So probably doesn't come naturally to modelers and economists. It certainly doesn't come naturally to engineers, but you need to be brave and you need to look on the bright side of what opportunities are out there and weight them appropriately. Don't get scared of risk and overrate your risk, because there will be markets, and the markets will be driven by the decarbonisation side of the balance, not the energy cost to some extent as well, which is why you're seeing 100-hour markets, why you're seeing longer duration to mix with solar to get you 24/7 green power. And that is valuable. And I'm not aware of a market that exists that values that and that could be put into a model right now. So I think if you can weight your risk adequately and you can be somewhat brave and get in there on a long duration market, you'll be rewarded in the long term.
Thanks, everyone. Great answers. Really like the views around the different diversity and the sustainability, and definitely resonated with the that changing needs into the future, energy depth, and I think there's a lot of synergies there around how you value long-lived assets, and that's obviously the same challenges we have in the transmission network as well. I've just got one final question. I think we've got a few government officials in the room, and probably a good opportunity to really ask, how do you think policymakers and funding agencies can help facilitate the development of these technologies, and what information would you like to see from these kind of forward planning publications that helps, I guess, direct your focus on those types and the scale of those technologies that are needed?
I'll start on this one. Look, I think there's a bit of public-private interface here, right, in terms of this. I think we've come from a long way back, and I think we'd almost be industry-leading now in terms of the amount of potential government support that's out there, the recognition for the need to develop a sustainable industry around transition within Australia. So there's so much that's been done right on both a federal and a state level, and I don't think you could be critical at all in terms of the endeavour that's out there. I think, from my perspective, it's helping smaller companies that don't have the, it's a way of phrasing this, necessarily the bandwidth or the horsepower internally to apply in the right way for a lot of the schemes that are out there. I mean, for instance, capacity investment scheme, it's very beneficial when you're looking at deploying a battery, but there is a lot of paperwork that needs to be done. And if you're a company like ours, we've got about 30 people, it's a huge amount of work to get in. So I'd say one takeaway for me would be, how can we make it easier for smaller companies to apply without changing any form of governance and things around that, but making it easier to supply. And then the other one is, and I think that's where, someone like Leanne and her endeavours are coming, is how can you bring government and private funding together to support something? Because I think that power of government really unlocks the door to that other avenue of funding. It's a huge tick from an investor's eyes if they see the government through a grant backing something, and then that unlocks a huge amount of capital. So it's that working together, I think, would be another thing to be able to do.
Yeah, I mean, we've had some great support from the Queensland government, so certainly a shout out to the IPP process that we were successful in constructing the electrolyte plant in Townsville, and we look forward to working with the new state government, continuing and with the federal government to hopefully achieve similar outcomes. The focus is definitely there on the upstream and midstream. I think we could improve on how we get deployment. How do we help customers use our technologies? And back to, I guess, the question I raised to Leanne after her keynote speech was, how can we engage as an industry with our customers more clearly, more concisely, show the value that is there, and that will be there in 10 years' time when a lot of the companies that are in this room will be at a point to scale and really be selling at full pace. Any investment in that space pays itself back through the supply chain. So if you're looking at efficiency of spend, you're not going to get better than putting it at the battery end and letting the supply chain grow through. You put that hand in glove with signalling, for a long duration market for specific technologies. I think you've got a pretty winning combination of stimulating a local manufacturing sector for certain battery markets. We've seen some GOCs in Queensland do this to some extent. There's 4-hour plus non-lithium tender processes that have been in play. I think more focus on that and how we can support the customers who are wanting to do that. And as Leanne pointed out, a lot of customers want to look at this and are very interested. So how do we make that efficient for them? How do we show that it's valuable to them? And I think that focus, putting government's focus and industry's focus on the very downstream, on the deployment end, is the place to go next. And it really supplies all the way back through to, whether it's manufacturing, whether it's mining, whether it's processing of some exotic material, it feeds itself back. And a lot of this spend is already budgeted. We need batteries for the grid. We know that. AEMO's modelled it. All the utilities know. We're spending the money anyway. Why don't we spend it on something that feeds back through a supply chain as well?
Yeah, so I just echo some of the stuff that has been said. I think the government is on the right track. I'm really grateful for all the support that has been announced and released. For example, Battery Breakthrough Initiative and all of these schemes. It's really good. I think the government is getting it, where that investment is required in that space. Without trying to sound critical or anything, I just want to pick up what Greg said earlier. So for startups / scale-ups, sometimes it's difficult to navigate this space. So, and also we hit a ceiling relatively quickly. The other thing is these key policies. One of them I mentioned earlier, like what is actually LDES? Is it 4 or 8 hours? It's important to have input, but I can't complain about this. We have had input, and the government is consulting a lot and is asking, so I'm quite happy about this, so more of that.
I don't comment on government policy.
Thanks, everyone. Sounds like there's already some great initiatives that are being made so far, and further work for collaboration in that space. Pretty almost at time. We might have.
Yeah, I think, Joe, I would just like to hijack just for a second, if I may. Thank you. I've got a question. I've got a question for Adam.
Won't get away.
Local content. How do we get local content? Let's assume we need to import the cells for the time being. How do we get local content into our grid-scale lithium batteries?
Yeah, feels like a policy question. I think one of the things we need to do is facilitate the development of our industry, particularly the AM and CAM industry. And I think there's some really great opportunities there through NRF and Battery Breakthrough Initiative to actually support some companies who are already active in this space, no pun intended, to actually help them with that scale. I can absolutely say there is demand from Asia, from Europe, from North America, for Australia to be able to provide these materials. They want to see stable, secure supply of Australian battery materials that can go into their supply chain. And there is tremendous demand, and notwithstanding the change in government in the US, I think that demand will not go away anytime soon. So how do we actually supercharge this? How do we actually build the infrastructure? Because when we talk about building this, we're trying to build hundreds and thousands of tons per annum of this stuff. And how do we get that throughput? And how do we meet the market in terms of the quality of material that we need? So we are building some partnerships at the moment with the US. One of them is with NREL, and they are actually establishing an evaluation program, which is the goal of that program is actually to fast track people through the qualifications process to get into battery cell manufacture. That's another big piece. These gentlemen here have spoken quite openly about the need for capital to see you through these points. Anyone here who's trying to qualify battery materials such as VSPC or others, you've got to do that on your own dime. And that costs a huge amount of money. So how can we shorten that time frame between getting your material ready, qualified, and an offtake agreement? Because the more we shorten that, the further you'll push that industry forward. Without that, it's going to be extraordinarily difficult.
Can I give a very simple and quick answer to that one? If you want more local content into the grid, start to look at different technologies like VFBs, where we can bring 75% local content.
No worries. Do we have time for any more questions? Or? Yep, okay. Well, I got that opportunity. I'd just like to take the time to thank Jeremy, Craig, Adam and Thomas for their time today, and just thanks to UQ for a great initiative and having me facilitate. So thank you.